Hey guys, Alex Noonan from Noonan Labs here, and today I'm going to be answering the question, what is data engineering? Because people ask me all the time, they say, Alex, what is data engineering? Why do we need it? And who cares? In this video, I will answer all of those questions, as well as describe some concepts and common tools that are used by data engineers. Data engineering is a field within data science focused on the development, construction, and maintenance of systems and infrastructure that enable the collection, storage, processing, and analysis of large volumes of data. To better illustrate what these tools and concepts look like in action, I created this simple architecture diagram of a data system for like an e-commerce company. And from here, we'll be able to see like what concept is used here and what is a common tool for that. So without further ado, let's jump into it. So moving left to right, we'll start at where the data begins in these source systems. And being a system admin doesn't really fall under data engineering roles and responsibilities, but you'll find yourself in one way or another doing that or suggesting actions being taken, whether that's adding an additional field to a Salesforce object or creating an entirely new table in a Postgres database so you can capture the key events. And really, this stage is important to have that emotional intelligence when you're working with your stakeholders and can find alignment between what they want to accomplish and what you need as a data engineer. Next, we'll move into the ingestion layer. A common pattern that I do is the first stop that any data goes after it leaves the source system is into object store, whether that is cloud storage on GCP or S3 on AWS. A robust storage solution that you can just dump data in. Chances are you won't need it, but if you ever want to change schemas later on, you'll be glad you have the initial raw data. And you can compress it with Parquet to make the most out of the storage solution and set up like intelligent tiering in S3 to move to archive data as it's not used. Now, if your budget is kind of robust, you can use a tool like Fivetran, which is just point and click, moving the data around. But if you're a little more savvy from a like Python perspective, you can use a tool like DLT Hub, which is really easy to replicate your data from your source systems into your destination, whether it's cloud storage or your data warehouse. So a data warehouse is a cloud-based database that is optimized for doing analytical workloads. So it is a OLAP database versus an OLTP, which is like a transactional database. Some common cloud services that you can use for these are BigQuery with Google Cloud, Redshift with AWS, or Snowflake, which is available to deploy in any of the clouds. All of these are great solutions, and if you're just starting out, I would recommend something like BigQuery as it's pretty accessible. Next, when it comes to the transformations. So in order to load data into like a BI tool and it really have all the richness you need, it needs to be in like a star schema where you have a fact table in the middle, like orders, for example, and then you have different dimensions branching off of that, whether they are like date time, related to the customer, related to the sales rep, and so on and so forth. I won't go too deep into it, but a tool that I use to build my analytics models is dbt, as it is SQL based. It integrates well with all these data warehouse solutions and allows you to integrate tests into building your models, which leads me to my next point. You're going to want to have robust testing along your entire data journey. So you want to make sure that you have alerts set up to when a replication or ingestion job fails, when a DBT model fails, when values are out of limits, or you have too many duplicates. Those are all things that really takes and adds a richness to your data, because you're able to catch problems before they're in an end report and you have some executive asking you why the numbers don't match up. Because once you have that happen, trust in your systems and your abilities tends to degrade. So you want to minimize those, and the best way to do it is with robust testing. Now, what do you do with this data once it's clean, indexed, and tested and ready to go? It needs to be consumed. And whether it is a fancy pants BI tool like Looker or Tableau, or maybe you're meeting your stakeholder where they are with just a flat file CSV export or a screenshot of a dashboard or a chart in an email, all those things are considered data consumption. I also view machine learning and statistical processing as kind of in this consumption layer, as generally there's a fair amount of pre-processing needing to be done um, from inside your data warehouse before a data science can really make use of it and start to build models with that data. And finally, kind of tying this all together, you can use a process of reverse ETL to pull analytics data out of BigQuery or whatever warehouse you're using, or from a machine learning model, and push it back into the source system so the teams can have the data where they need it to be. And a lot of these tools and technologies, like as in ETL, which stands for extract, transform, and load, and the reverse of that, which is just moving from analytics to a transaction system, you're often just moving data around between point A to B. And this is why data engineering, they're kind of called data plumbers, because that's what we do. And it tends to be a kind of blue collar field where you're just tying systems together and you just need to make things work. Did you like the video? Make sure you subscribe so you don't miss any updates. And if you want to chat, make sure you reach out to me on LinkedIn or Twitter, and that's usually the best way to get in contact with me.